2.7. This will probably be the last section that I will do for the summer videos. Nonlinear inequalities, it's a review. It's on pages 11 through 13. So this first one is just going to review the idea of the quadratic that you can have. So first, x squared plus 5x minus 6 is greater than or equal to 0. As you have learned on several videos, you need to factor, you need to decide what type of numbers you're looking for here, 0 and 1. We know our zeros are negative 6 and 1. I make a number line with my negative 6 and 1 in number line order. I put the vertical lines, excuse me, I put the vertical bars in to put our zeros on. Negative 6 makes x plus 6, 0. 1 makes x minus 1, 0. Finding their products and looking for where I'm 0 and positive, I see that my solution is x is less than or equal to negative 6, or x is greater than or equal to 1. And you can write it either way. Question 2 is similar. Again, I factor it, only this time I say strictly less than 0, which means negative. So negative 4 makes it 0, negative 3 makes it 0. The product, again, positive, negative, positive. I don't want the zeros, I just want the negative. So my answer is negative 4 is less than or equal to negative 3. Then let's come to the 4 special cases in review. What happens when you have a quantity squared? Well, when you have a quantity squared and you square any number, you either get a 0 or a positive sign. So I don't need to write the factors down more than once. Negative 2 makes it 0. And I want to know where it's positive and where it's 0. And that's everywhere. So that's all real numbers. Again, these are all going to be quantity squareds. And so when I square my negative, I want a positive. So now I'm asking to be less than or equal to 0, but I can't be less than or equal to 0. So the only thing I can be is 0. So in this case, I'm simply negative 1. Now I want to be strictly positive for the quantity x minus 3 squared. And notice that doesn't allow the 3, but it allows all the other numbers. So if I don't want inequality notation, I can simply say x is not 3. Or I have, as if I write it in interval or inequality notation, x is less than 3, or x is greater than or equal to 3. And then the final case is when it's that I want it negative. Well, I'm not allowed to be 0. I'm not allowed to be positive. Hence, there is no proper solution. And so the solution is no solution. Now, you can do these on the calculator, and there are 2 ways that you can do these on the calculator. One is graph mode, and the other is calculator mode. In calculator mode, you would need menu, mode, algebra, polynomial tools, find roots. Once that shows up, since it's already set up to be second degree, for this case, you would just say okay, and then you would enter the coefficients of 1, 6, and 3. And it just gives you these 2 numbers as the solution. But what you need to know is that the end behavior of x squared plus 6x plus 3 has the graph looking like this. And so the part above the x-axis is where you're going to be positive. Below the x-axis is where you're negative. But remember, I don't care about the y's, just the x's. So the x's are between. And since I'm allowing 0, I have closed brackets. I could have done this in graph mode. So I'd graph the function, and then menu, analyze zeros. I find the zeros the same way, only now I see the picture. And so my zeros are there. It's not telling me the solution. There are more ways. This is the only way, but I would have found the zeros. These are just 2 ways. Now I want to solve rational inequalities. And so I need the common denominator. No, I can't multiply through like we did when we were playing what's missing, although we still say what's missing. Normally I would have just worked with the numerators. I wouldn't have shown this in-between work here. I would say 3 needs x plus 4, 5 needs x minus 4. I would have gone and done the multiplying, and so the next step from up here to here would be this step, the one that's in blue. But now this one, I want to show the tricky one first. I common factor a negative. Now notice this is a negative 2, but I want everything on this side to have a positive x or a positive coefficient. And notice the negative 2 is a negative coefficient. And so since everything needs a positive coefficient, I need to negate. If I negate the left, I have to negate the symbol. Now I could have done it here and made this 2x minus 32 and then reverse the inequality there. It's your choice. But either way, the less than becomes a greater than. And now we need to remember when we do an inequality, even though it says I can be 0, denominators can't be 0. And so the 4 and negative 4 have to have open circles, but the 16 is a closed circle. We play the same game, and we see the final answer is negative 4 is less than or equal to 4, or x is greater than or equal to 16. A couple of more examples, again for this one. I know I've shown you this work where I'm putting them in, I'm multiplying, I move it over. But what I would have done in reality is said 5 times this and gotten that. And I would have had that times each other, gotten that. And I would have just taken the numerators, and this would be my first step. And so now I have 2x plus 28. I factor out the 2. Notice it says greater than 0. So none of the numbers 6, negative 2, and 14 are allowed to be 0. I made my chart as usual. I'm looking for positives. And so 14 is less than or equal to x is less than or equal to negative 2, or x is greater than 6. And then the very last one of this form, much of the same thing. I would have put the x plus 3 here, the x there, and this would be the first step I would show on my paper. And once again, I've got an equal to 0 in there, but denominators can't be 0, so I can't use 0 or negative 3. Those must be open circles, but the negative 6 can be a closed circle. I made my chart. X is less than or equal to negative 6, or negative 3 is less than x is less than 0. Now we're going to do domain, which is going to do the same thing, and it's the domain just of square roots I'm worried about right now. So the radicand that is the stuff inside, must be greater than or equal to 0. Denominators can't be 0. The thrust of this is numerators can, denominators can't. So when I see this expression, I immediately turn it into greater than or equal to 0. Numerator, you can equal 0. Denominator, you can't. I make up my chart just like we did a few minutes ago. And I see negative 3 is less than or equal to x, or x is greater than 3. Same difference here. Only now my x has a negative, so I've circled the parts that must be negated. And so doing that, the greater than becomes a less than. Again, the numerator can be 0, but the denominator can't. Every single time, I'm looking for negatives. And so 2 is less than x is less than or equal to 4. A couple more of these and we will be done. So for this next one, again, I set up with a 4 minus x to practice negating. Notice this is always greater than, so if you have to negate, it's always less than. Again, the numerator can be 0, but the denominator can't be 0. And so now in this case, negative 1 is less than or equal to x is less than or equal to 4. Then one that's really pretty easy, no thinking required, because there's no trickery, no chicanery. Just the numerator can be 0 and the denominator can't. And I still want the positive. So x is less than or equal to -2, or x is greater than 6. Now again, I can have quantities where I need to factor, so I did exactly one where I factored with no chicanery up my sleeve. So the denominators of 2 and -2 can't be 0, but 3 can be 0. I went ahead and filled in my chart. So -2 is less than or equal to 2, or x is greater than or equal to 3.